Hello, in this video we will go over properties of a determinant and use those properties in row operations, or also known as commandments, to help find the determinant of a 3 by 3 and a 4 by 4 and beyond more easily. So yeah, we've already kind of talked about determinants, how to find a determinant of a 2 by 2 and a 3 by 3. Um, but we really didn't go over how to find the determinant of a 4 by 4. There's going to be a much easier way. So this is what we're gonna get. That's what we're primarily gonna learn. It's basically just an easier way to find the determinant. So yeah, determinant of a matrix. So let's kind of review the determinant and their properties. So if you're given a 2 by 2 matrix, like for example, given A is a 2 by 2 matrix, A, C, B, D, then the determinant is it's going to be, so the straight line means determinant. Basically you multiply AD minus BC. And if it doesn't equal to zero, that means you have a determinant. If it is, you don't have one. And then to find the inverse of a 2 by 2, uh, you don't have to do row operation. You just do 1 over d determinant of A of d. So you basically flip this. So it's d minus d, d negative c, negative b over A, right? You flip these. So given A equals matrix A, B, C, D, E, F, and G, H, I. So this is a 3 by 3. So if you recall, how do you find a determinant of a 3 by 3? Um, you can use expansion by cofactors or minors. Uh, I, I, I think you'll learn more. This is like Kramer's rule. So whatever this number, this is going to be positive, this is going to be minus, positive, minus, positive, minus, positive, minus, minus. Positive minus positive. So you might want to write this down because we'll use that. So let's do a simple one. Example, calculate the determinant of this 2 by 2 matrix. So the determinant of A is going to be two straight lines, and then it's just going to be 5, 2, negative 1, 4. So it's pretty easy for a 2 by 2, right? You just multiply 5 and 4, minus, and then put a little parentheses, or you could just, yeah, bracket, and then it's 2 times negative 1. So when you put it all together, you get 5 times 4 is 20, minus a minus 2. 2 negatives becomes a positive, so that's 22. Okay. Let's move on. What about this matrix, a 3 by 3? So you can expand using cofactors. So I I just wrote this rule down. So we know that this is plus minus plus negative 1 plus negative positive minus. What do these symbols mean? So what you could do is you could take any row or any columns you like. So what if I decide to take uh, this column, right? So according to this chart, this cofactor of 2 is going to be positive, this 0 is going to be a minus, and then this 1 is going to be a positive, right? And then what you do is do this. You're going to so start with the 2. This is positive 2. You're going to put a 2 here. Then it's going to you're going to form a 2 by 2 matrix. And what you're going to do is kind of like visually ignore anything. So you're going to ignore 1, 2, and then 0, 1. So basically you're ignoring this and this, anything that has a 2 here. And then you're left with 3, negative 1, 2, 0, right? Okay, and then we said that we're going to choose 0 as my next cofactor, so it's going to be a minus 0. And honestly, I don't really care because anything times 0 is 0. So, but if you're curious, you're going to get rid of anything that's this row related to 0. So you're going to get rid of this row and then this column. So you're left with 1, 2, 2, 0. And then what about this one? This one is a positive, so because of the cofactor, so it's going to be +1. And then you're going to ignore anything that has this 1 here, and then this column 1 here. So you're left with 1, 2, 3, -1, right? Okay, so now we have a 2 by 2 matrix. We can easily find the determinant of a 2 by 2. So let's start here. This one right here. So that's going to be 2, bracket, and then just it's going to be 3 times 0 minus 2 times -1, right? Over here, I don't care because anything times 0 is just 0. Over here, it's going to be 1 times -1 minus 3 times 2, bracket. Okay, and you get, oops. Okay, 3 times 0 is 0. 2 times -1 is -2, and then you have a minus, so that's +2. And then minus 0 plus 1 times -1 is -1, minus 3 times 2 is 6, so -1 minus 6 is -7. Put it all together, 2 times 2 is 4. 1 times -7 is -7. 4 minus 7 is -3. So the determinant of that 3 by 3 matrix is -3. Okay. Later on, there's an easier way. Okay. So yeah, the next example is also a 4 by 4 matrix. So we could expand using minors, expand by cofactors, right? So you have, this is a 4 by 4. We have 2, 5, 1, 4. This is a 4, a 1, a 6, a 3, a 1, 0, 2, 4. And then I put the symbol, the sign for the cofactor. So this is positive, minus, positive, minus, minus, positive, minus, positive, positive, minus, etc. So you can use any row or any columns for your cofactors. So I'm going to use the first row, right? So it's going to be 2. And then you're going to have to use like some kind of pencil to get rid of, because it's kind of hard to do it visually, but you're basically ignoring anything. You're going to ignore the row and the column that's related to this too. So you're like going to ignore it, or use a pencil or a pen and just like block it off. And now you're left with 1, 6, 3, 3, 7, 2, 0, 2, 4, right? Now do the same thing with 5. And we said that this sign is going to be negative, so it's going to be -5. And like I did before, ignore the row and the column that has this 5. So when you do that, you're left with, right? So ignore this row and then this column, and then you're left with 4, 6, 3, 5, 7, 2, 1, 2, 4. Keep on going. The next one is 1. 1 has a positive sign, so it's going to be +1. Ignore the rows and columns with 1, so you're left with 4, 1, 3, 5, 3, 2, 1, 0, 4. The next one is on 4, and that has a negative sign, so it's -4. And you're left with 4, 1, 6, 5, 3, 7, 1, 0, 2. Okay. Then what you have to do is then you break down the 3 by 3 matrix and turn it into a 2 by. So it's like the same. You take the cofactor. So for example, this matrix is a 3 by 3. So you have to take the cofactor, do the same process as we did. So, okay, so it's kind of tedious. So I'm just gonna do the work for you. So for this one, I'm gonna use this row. So you get 2 bracket, and then if I'm gonna use this row, this has a 1 and that's a positive one. So it's gonna be 1, and then you're left with uh the matrix 7, 2, 2, 4, and then keep on going. Now we're gonna use this 6. And then 6 is, according to the symbol, it's going to be -6. Ignore the row and the column that has that 6. So you're left with 3, 2, 0, 4. If you need to pause the video, it's fine because I am going a bit fast. And then 3. This symbol is a positive 3 because of the cofactor. It's +3. And then ignore the row and column with 3 so that you're left with 3, 7, 0, 2. I kind of lost. Okay, so I need more space, so I'm gonna move head to the right. Okay, so continuing off, sorry, I'm just have to, I'm out of space, so I'm gonna move it to the right. So continuing off, you're gonna get 2 bracket 1 times 7 times 4 minus 2 times 2 minus 6 times 3 times 4 minus 0 times 2 plus 3 and then 3, 2 minus 0 times 7 bracket. And then for the 5, it would be -5 bracket 4, and then you're left with 7, 2, 2, 4, and then -6, uh, -6. It's tedious, but when you do it, your final answer should be -36. Okay, so the point is, I don't want to do all that work of a 4 by 4 matrix, right? I don't want to do it, so there is an easier way. So before we figure out the easier way, let's go over the properties of determinants. So you kind of know this already. A square matrix is invertible if and only if the determinant of A does not equal 0, right? If it equals to 0, then you don't have a determinant. If an A is an n by n matrix, then the determinant is an A transpose equals determinant A. So that's important. If A is an n by n matrix, then the determinant of AT is equal to the determinant of A. So the determinant of A transpose equals to the determinant of A. For an n by n matrix, A and B, the determinant of AB equals to determinant of A times determinant of B. So go ahead and write all these important notes because we're going to need these when we do the next examples. Next one is for an n by n matrix A, determinant of AN is equal to the determinant of A times the determinant of A. Oh, this is also important. If A is a triangular matrix, then the determinant of A is the product of the main diagonal. So what do I mean by a triangular matrix. It's basically where all of these are zeros, right? That's how you have it. Yeah, if these are all zeros, the determinant of this is just the diagonal, the multiplication of these diagonals. So you multiply 2, 1, -3, and 4. That's so much easier. So that's what we might have to do for the next example. So the determinant of this matrix is -24. Okay, so more rules. Let A be a square matrix. So if you have a square matrix, if a multiple of one, so write this down too. If a multiple of one row of A is added to another row of A to produce a matrix B, then the determinant of B is also equal to determinant A. So um, when you do row of operation, right? You've done row of operation before. And if you add another like row one plus row two, meaning you don't multiply by scalar, if you're just adding rows, the determinant of the left is equal to the determinant of the right. It just stays the same, right? The determinant does not change. Uh, what happens if two rows of A are interchanged? So if you switch rows, like for example, row 3, when you're doing a row of operation, row 3 is switched with R2. So when you switch rows, the determinant of B is equal to the negative determinant of A. So yeah, when you switch rows, the determinant changes sign. Matrix B is the new matrix after performing the new row of operation. Okay. Rule 3. If one row of A is multiplied by K scalar to produce matrix B, then the determinant of B is equal to the K times determinant of A. So when you're make more sense. When you multiply by a scalar and it's when you multiply by a scalar of the same row and it goes to the same row, that changes your determinant. So it's going to be K times determinant of A. So for example, 1/2 row 1 plus row 2 gives you row 1. Okay, that changes it. Because you're multiplying by scalar and it's 1/2 times row 1 and it's still messing with the row 1. Now, what if it was like 1/2 row 2 and that gives you row 1? So this scalar is not going with row 1, so this does not change. So scale, then multiply by scale value. Okay, so let's do one. Example 4, compute the determinant. The determinant of A is equal to -2. Find a determinant of A7. So to find A7 is basically -2 raised to the 7th power, which is -128. Because of that one rule, if A is an n by n matrix, then determinant of AT is determinant of A. Okay. B, find the determinant of A equals -2. Determinant of A equals -2. Find determinant of AT. So the determinant of A transpose. So A transpose is equal to determinant of A equals to -2. That's it, because that was that one rule we talked about. So A transpose is equal to the determinant of A. So it's basically -2. Okay. Number 5 says verify the determinant AB is equal to the determinant of A times determinant of B. So yeah, if A is equal to the matrix 3601, if A is equal to the 2 by 2 matrix 3601 and B is the 2 by 2 matrix of 2504, verify that determinant of AB. Okay, so if you multiply those two matrices, AB is equal to this. So we're not finding the determinant yet, we're just multiplying the matrix A and B. So it's going to be 3 times 2 plus 0, 5, right? So we're just like multiplying this by this. And then that will be this number here. And then you do the same process for the other number. So this would be 3 times 0 plus 0 times 4, right? So basically multiplying this by this. And that'll be this number. And then it's going to be this times this. So it's going to be 6 times 2 plus 1 times 5. And then the same process for this, 6 times 0. So that would be 6 times 0 plus 1 times 4. Right? Okay, so when you clean that up, when you do the algebra, you're going to get this matrix. You get AB equals to 6, 17, 0, 4. Okay, now let's find the determinant of AB, which is pretty easy now because it is a 2 by 2, right? Just, yeah, it's a 2 by 2 matrix. It's easy to find the determinant of AB is equal to 6 times 4 minus bracket 0 times 17. And when you put that together, 6 times 4 is 24 minus 0 is 25. Okay, so the determinant of AB is 24. What about the determinant of A? Yeah, we found the determinant of A times B. What about just regular determinant of A? So A was 3061, right? So the determinant of that will be it's a square matrix, so it's pretty easy. So it's 3 times 1 minus 0 times 6, and that gives us 3. And what about the determinant of B? It's also 2 by 2 matrix, which makes it easy. It was 2, 5, 0, 4. So it would be 2 times 4 minus 5 times 0. And that is 8. So is that true? Does the determinant of AB equals to the determinant of determinant does is this true? Does the determinant of AB equals to the determinant of A times the determinant of B? I believe so, yeah, right? Determinant AB was 24. The determinant of A was 3. The determinant of B was 8. Yeah, 24 does equal to 24. Okay. Okay, let's do example 6. Illustrate the property of determinants. We have illustrate the property of the determinants. We have A, B, C, D, and then it's C, A. So determinant A is A, C, B, D, and then determinant B is C, A, D, B. So if you look at it very carefully, what's really happening, it looks like you switch interchange rows, right? You interchange the row. So row one is switched with row two. So what does that mean? According to the rule, if you switch rows, uh, determinant B is equal to the negative of determinant A, right? So this is just rules. Will be helpful when we do the examples. So what about this rule? So we have determinant A, which is 2 by 2 AC BD, and it's now here's determinant B, was also 2 by 2. It's A plus KC, C, and then B plus KD, D, right? So what did we do? It looks like we did some kind of row of operation, right? So if you look at the first row, it looks like you multiplied by a scalar K plus row one because row one is C. So yeah, so we did a row operation for row one. It's K times row two, or a scalar times row two plus row one, and that gives you row one. So we did a multiple of one row and added to another. We added two rows, thus no change. Determinant B equals to determinant A. Why is that? Why is there no change? Because this scalar went with row two, and then our final answer, our final product was related to row one. Now, if it was K row one plus, I don't know, row two, and then that gives us row two. See how this scalar is related to row one? Oops, this should be row one. If it was this, if it was K times row one plus row two gives you row one, then something has changed. This scalar has to be related to your new row, which is row one. So if these rows are the same, it's different now. But because they're different, there's no change. Let's look at rule 8. You have this matrix A, 2 by 2, and it's 2, negative 3, 2, 8. And I make this new matrix is B, which is also 2 by 2, 2K, negative 3, and 2K plus 8. So what happened? It looks like we multiplied row 1 by a scalar, and then that gave us your new row 1. So this changed, right? This scalar went with row 1, and this is row 1. So this does change a bit. So determinant B is equal to the K times determinant A. So yeah, determinant B is equal to the scalar of row 1. So whatever this number is, it's going to be this, that's your K value. So we scale the row and change that row. So yeah, okay. And this one, let's see. This is your original matrix, and this is your new matrix. So it looks like the top row and the bottom row has been flipped. So you interchange or you switch. So what that means, if you switch rows, determinant B equals to negative determinant A. So if they tell us that determinant A is negative 114 and determinant B is positive 114. So what that means is determinant B is equal to negative determinant A. So that's 114 equals to negative 114. Okay, let's look at rule 10. Here we have this matrix, this 3 by 3, and it looks like on this matrix they factor out, or they took a multiple or scaled it. Yeah, or a multiple, right? So if you look at the first row, I think they multiply by the scalar 1/2. So 1/2 row 1 gives you row 1. And then, yeah, determinant B is equal to, so that means determinant B equals to K times determinant A. So 86 equals K times 172. The K is not but the scalar number or 1/2. So in our case, our K is 1/2. Okay, so if you look at example 11, we have this matrix 1, 2, 5, 3, 0, -4, -4, -3, 7, and then our new matrix is 1, 0, 5, going by columns, 1, 0, 5, 3, -6, -4, -4, 5, 7. So we did some kind of row of operation, and I think we messed with row 2, right? Because row 1 looks the same, row 3 looks the same. The only thing that's changed is row 2. And we did was we multiplied -2 by row 1, or the scalar -2 by row 1, plus row 2, and that gives us your new row 2. So this doesn't change because this scalar, -2, went with row 1. And then our new output is row 2. So they're not the same row. If they were, it would change. So we did not scale the row, we changed it. Instead, we added a multiple of another row, no change. Number 12 says, find the determinant using row of operations. So here we have this 3 by 3 matrix, 1, -1, -2, 5, -4. So I'm going by columns. 1, -1, -2, 5, -4, -7, -6, 4, 9. It's a 3 by 3, right? So I wrote down this rule. Remember, if you're just for a row of operation, if you're adding, the determinant doesn't change, right? Determinant B equals to determinant A. If you switch, if you switch rows, determinant B equals to determinant of A. Actually, I think one of them becomes negative, right? One of them becomes negative. And then if you scale, uh, as long as the scalar goes with the new final row, it's going to be K times the determinant of A. So find the determinant using row of operation. So we don't want to use minors, like Kramer's rule, right? You don't want to do that. Instead, we want to do row of operation. So what I would do is first is let's try making the matrix into a triangular matrix. So what do I mean by a triangular matrix? Basically, I want this -1, I want this -2, and I want this -7 to a 0. So step 1, let's try to make it. Right? Try making -1, -2, -7, 0. So let's see here. Let's start with this -1. Let's try to make that 0. So that means what we would have to do is you would do row 1, plus row 2, and that will give us your new row 2. And then what maybe the next thing I would do is maybe make this -2 and -2 into 0 by doing the row of operation of maybe making 2 times row 1 plus row 3 gives us row 3. So keep very good track of your commandments because we're going to use those commandments later. So now our new matrix will be, the first row hasn't really changed. 0, 1. So the second row now becomes 0, 1, -2. And then the third row would be 0, 3, -3. Okay. The next thing I would do is make this 3 into a 0 because I really want that triangular matrix. So how would I do that? Maybe, uh, so let's mess with row 3. So because this 3 is technically in row 3, maybe we could use -3 row 2 plus row 3 gives us row 3. You get 1, 5, -6, 0, 1, -2, 0, 0, 3. Oh, this is. And now you have a triangular matrix. So the question says find the determinant using row of operation. So our determinant is basically the multiple of these numbers, or multiplying these numbers. So it's 1 times 1 times 3, which is 3. So just a, so you know how I said keep track of your commandment? Um, row 1, if you look at the first commandment, row 1 plus row 2, that doesn't change our determinant because when you're adding or subtracting, that doesn't change the determinant. This commandment, 2 row 1 plus row 3 gives us new row 3. This doesn't change our determinant because the scalar has to be with the new row. So this was only related to row 1, and our new row was our new final row was row 3. It would have changed if this was row 2, right? This one, yeah, when you're adding subtracting rows, it doesn't really change the determinant. So we did rows, we did a scale, but we didn't change the scale. We didn't scale the row. We didn't scale the row that was changed. That means the determinant of this matrix is 3. Okay, let's do example 13. We have this 3 by 3 matrix going by columns 2, 5, 7, 4, 6, 6, 6, 7, 10, and the same direction. We got to find the determinant of this. So I rewrote these rules because I think this is going to be helpful. Um, so yeah, adding, subtracting determinants doesn't change the determinant. Switching it makes the determinant of a negative. If you multiply scalar, uh, it's going to be k times determinant of a. Okay. So what's in the first step is first make a triangular matrix. Okay, that's the first thing I would do. So how would I do that? Make a triangular matrix. Uh, what would I do first? Maybe I should make that 2 into a 1. So maybe I could, yeah, first would be 1/2 row 1 gives you row 1, right? And maybe that would be a lot easier. So this would equal to, now this gives us the new matrix 1, 2, 3, 5, 6, 6, 10. The next thing I would do is maybe make this 5 into a 0. So to do so, I would have to do this. Yeah, I'm going to make this 5 and this 7 0, and I'm going to do it all at once. So starting with the 5, it would be -5 row 1 plus row 2 gives us your new row 2. And then for the 7 to make this 7 to a 0, it's going to be -7 row 1 plus row 3 gives us your new row 3. Okay, so you're left with, so when you do that, you get this. So first row stays the same. So you're still left with 1, 2, 3. The second row is 0, -4, -8. The third row is, I believe it's going to be 0, -8, -11. Okay, and then the next thing I will do is maybe really want to make this -8 into a 0. So the next order of operation is row 3. So to make this -8 into a 0, I would have to multiply -2, row 2, plus row 3 gives me my new row 3, which is this going to give us this final matrix: 1, 2, 3, 0, -4, -8, 0, 0, 5. Okay, so what would be the determinant of this matrix? Well, we have this triangular, they're all zeros. So now you're left with, you just multiply these numbers, 1, these diagonals, 1, -4, and +5, which gives us -20. Okay, but uh, we need, this only gave us determinant B. So determinant B gave us 1 times -4, +5, which is -20, right? That's determinant B. I want to find determinant A. So this is where we had to keep track of our command names or row of operation. So let me rewrite our, I can rewrite our commandments right here. Okay, so our first commandment was 1/2 row 1 gives us row 1. So we definitely scaled our row, and it gave it, this scalar was related to our new row, so we definitely scale. So that kind of changes it. Okay. The second commandment was -5 row 1 plus row 2 gave me row 2. So as you can see, we are adding, and then we also have a scalar. But if you look at their scalar, -5 row 1, it doesn't belong, it gave us row 2, so they're not related. So scale, we did not scale the row. That was changed. I mean, it was just simple addition. The third one was negative 7 row 1 plus row 3 gave us row 3. So as you can see, the scalar negative 7 times row 1, it's a scalar and there's addition. So addition doesn't really change it, but the scalar is not related to the new row of operation. So we did not scale the row that was changed. Okay. And then the last commandment, it was negative 2 row 2 plus row 3 gives me row 3. As you can see, the scalar negative 2 is not related to row 3. I mean, the scalar negative 2 is not related to this row, so that does not change. We did not change the row. We did not change, or we did not scale the row that was changed. Just added. So we can say determinant B is equal to K times determinant of A. Because remember, in one of the row of operation, the first one was we multiplied by a scalar, and that was we multiplied 1/2 row 1, and that gave us row 1. This scalar is related to row 1, and it gave us row 1. So it's going to be this. We use this rule. And our K is whatever your scalar was, so in our case it would be 1/2. So it's going to be 1/2 times the determinant of A. And we know that the determinant of B was negative 20 from the triangular matrix, right? Remember when we did all that zeros and then we multiplied that by the diagonal, we got a negative 20. So now we can find determinant A by getting rid of this 1/2 by multiplying both sides by 2. So this is going to be negative 4. So determinant of A is equal to negative 40. Okay. So yeah, so that was a 3 by 3 matrix. So we can do the same process for a larger matrix, like a 4 by 4 and beyond. So let's do example 14. Oops, let me go down more. Okay, 14. So the direction says find the determinant using row of operation. And this is a kind of matrix. This is 1, 2, 3, 4. It's a 4 by 4, so it's pretty large. So the same rule, I keep up the same rules to just make it easier. Addition doesn't change it. Switching, if you switch rows, it's going to be negative determinant of A. If you scale it, it's going to be K times determinant of A. Okay, so first step is, so wait, this is matrix B, by the way. I think B is your original, and then determine the A is the new one. So first step is create a triangular matrix. By making 2, 2, 7, 9, 7, 2 zeros, right? So just go up. Basically, I think what we want. So we want this to be all numbers. Then I want this to be 0. I want this to be 0. I want this to be 0. This 9 to be 0 and this 7 to be 0. So we have quite a few operations, row of operations. They'll start with the 2. Let's make that 0. So, and then let's make the other 2 into a 0. So I'm going to do 2 row of operation. So I'm going to mess with row 3 and row 4. So row 3 will be -2 row 1 plus row 3, and that'll give us my new row 3. And then for my row 4, it's going to be -2 row 1 plus row 4 gives me a new row 4. Okay, so when you do that, you get this matrix. So you get 1, 2, 3, 4, 0, 0, 0, 0, 3, 0, 2, 0, 5, 1, 3. Okay, next thing I would do is what will they do? Oh, I would make this 5. Yeah, I would make this 5 right here into a 0. So it's going to be 1/5 row 2, and then it gives me row 2. So that's going to give us this new matrix. 1, 2, 3, 4, 0, 1, 0, 0, 0, 3, 0, 2, 0, 5, 1, 3. Then what I would do is I'm going to mess with row 3 again, and I'm going to mess with row 4. And yeah, I'm going to mess with those 2 rows. So my next row of operation is going to be -3 row 2 plus row 3 gives me new row 3. And then I'm also going to mess with row 4, and I'm going to do -5 row 2 plus row 4. That gives me row 4, my new row 4. So when I do that, I get this new matrix. 1, 2, 3, 4, 0, 1, 0, 0, 0, 0, 0, 2, 0, 0, 1, 3. Okay. Oh, and then because I don't want this 0 to be 0, I want it to be a number. So maybe if I switch row 4 with row 3, so we're switching rows. So that definitely changes things. So yeah, row 3 switches with row 4, right? Because I don't want that 0 there. So I get this 1, 2, 3, 4, 0, 1, 0, 0, 0, 0, 1, 3, 0, 0, 0, 2. Okay. So yeah, this is definitely determinant B. So what is my determinant for B? We got the zeros. Now we just multiply the diagonals. So it's basically 1 times 1 times 2. And that gives me 2. So the determinant of B is 2. But I don't want determinant B. I want to figure out what determinant A is. Okay. So this is why we need to rewrite our commandments because that will change stuff. So it's okay. I wrote down all the commandments. So I'm just going to rewrite the commandments. Or when I say commandments, I mean row of operation. Okay, so my first commandment was -2 row 1 plus row 3 gave me new row 3. And unfortunately, this is a scalar, but the scalar was related to row 1 and our new row was row 3, so they're not the same. So did not scale, so it's just addition. So it doesn't change. Second commandment was -2 row 1 plus row 4 gave me a new row 4. So it's also a scalar, and the scalar is related to row 1, and our new output was row 4. They're not the same. So it's just addition. Doesn't change anything. Third one is 1/5 row 2 gave me new row 2. It looks like we have a scalar of row 2 and our final was row 2. So they're the same, right? If the scalar is the same with the new row, so you could say yes. We scale the row. They're with being changed. So I believe that's going to be what is it? The scalar rule. So it's going to be determinant of B equals K times determinant of A. Okay, so that's going to be handy. Anything else? Let's see. Fourth, fourth one was -3 row 2 plus row 3 gives me row 3. So let's see. Scalar of row 2, but that doesn't, our new was row 3, so it did not scale, so it's just addition, so nothing changed. The fifth one was this -5 row 2 plus row 4 gives me new row 4. So the scalar is -5, but that was related to row 2, and our new output was row 4, so it doesn't change, just addition. So nothing changed. And then the sixth last one was we did do a row switch, a switch row. So row 3 was switched with row 4. So if that's true, that means it'll be the third rule. I mean the second rule, which is determinant B equals to negative determinant of A. So there's only two things that really changed. It was on the fifth commandment, the third commandment, and the last commandment. So we can say on the third commandment, we could say determinant of B equals to negative K of determinant of A. So we figured out what determinant B by multiplying that triangular, the diagonals, which is 2. And what is our K? It was the scalar for row 2 was 1/5. So it's negative 1/5. And it times it by determinant of A. We don't know what determinant A, so that's why we're going to solve for determinant A by multiplying, and we know this negative 1/5 by multiplying both sides by -5, right? So that's negative 10 equals to determinant of A. So determinant of A is negative 10. Okay, let's move on to 15. Okay, 15 says find the determinant if determinant of A equals to this, and that equals 4. So this is like, so find the determinant if determinant of A is equal to 4. And in part A, we have this matrix. So if you compare A with the original, what's happening, I think you're just multiplying row 3 by scalar 5, right? So yeah, so it's going to be 5. I think you're multiplying by 5, right? Yeah, by the scalar 5. So it's 5 row 3 gives me row 3. That is a scale. So we said that the determinant, we're going to use this rule, the determinant of B equals to the K times determinant of A. And they tell us that determinant of A was 4, so that's given. So it's going to be 4. And what was our K value? 5. So we found determinant B, which is positive 20. Okay. Let's do the next one. Part B. Part B, we have GHI, 3D, 3E, 3F, ABC. So if you compare that with the original, there's a few things that's happening. It looks like there is a switch between row 1 and row 3, right? So if you compare this with the original, there is a switch of row 1 is with row 3. And there's also a scalar, so it's going to be 3 in the second row 2. You're multiplying the second row by 3, everything by 3, right? So it's 3 row 2, and that gives my row 2. That is a scale. So let's see. On the first, if we did a switch, so on the first one, it would be determinant of B equals to the negative K determinant of A, right? Because that's the rule. If you switch it, it's going to be that. So it's going to be determinant B equals to -3. The scalar is -3. And the determinant of A was given with just 4. Oh, no, sorry. It's this one. Oh, you know why I put a minus? Because we switched it and we did a scale. So there's a minus, and that's why we put a minus. That's why I put a negative K. So that's going to be -3 times 4 is -12. So determinant B is -12. think there's like a C and a D, and then we're done. So let's look at C and compare it with the original matrix. So in the what's happening, I think there's only one row of operation. It is you're messing with they messed with row two. So it's going to be 2 row 1 plus row 2 gives me new row 2. So is this a scalar or addition? Uh, so the scalar is 2 and it was multiplied by row 1, but our final output was row 2, so they're not the same. So that means determinant of B is equal to determinant of A. So that means determinant of B is also 4. Okay, last one. Okay, last one. So compare this with the original, and it looks like it's messed with row 1. So I mean, row 2 is being messed up. So it looks like they did a 2 times row 2 plus row 1 uh, gave me row 2. So it looks like we have a scalar and 2 times row 2, but our final output is row 2, so it does change. So did you scale the row that was being changed? Yes. So you're going to use this rule. Determinant B is equal to K times determinant of A. And that means it's determinant B. The scalar is 2, and the determinant of A was given, which is 4. So the determinant of B is 8. Okay. Yep. Okay. So yes, so we will stop here.